Hi, Cullen. This is the section of problems on volume that you sent me today. This is the code that I see in the corner of the page. Volume is the three-dimensional measurement. Remember last time I told you that we have a one-dimensional measurement, two-dimensional, and three-dimensional. This one we call length or line. This one we call area. 3 dimensions is volume. The most fun thing about volume problems is we get to draw fun pictures and imagine them. The volume of a rectangle is 5 feet high, 6 feet thick, 13 feet long. Let's visualize that. It always helps to draw a picture. And this is my moment to tell you that art and math are very closely related in our brains, very closely related, far more than our culture usually gives respect to art. So, taking a moment in the middle of a math problem to draw a picture and to try and get our hands around the problem that way with a diagram is absolutely the wisest way we can approach the problem, to help our brains approach the problem, right? It's very important to me that we use brain science, which is a really hot field with a lot of emerging findings. It's important to me that we use what we learn about how our brain works to help it work better. So what I'm telling you is drawing the picture isn't just busy work. It will help you learn and understand better what we're doing. Okay, so here's our rectangle, 5 feet high. That's usually considered to be this dimension, height. 6 feet thick, that's this dimension. And 13 feet long, that's usually the front edge. Decoding these words is important so that you understand what it is that you're drawing. The other disclaimer I always put on my figures, and you should too, is they may not be proportional. This one turned out pretty well. This one looks kind of proportional to that. This one's a little bit bigger than that. It doesn't have to be perfect is what I'm saying. Try to make it the best you can, but don't worry about it. Okay, so now we have a diagram, we have a shape in mind. We want to figure out how do we find the volume. Super important formula. The volume equals the area of the base of the object times the height. I have my students write down all the formulas inside the cover of the notebook. They're usually using spiral notebooks, which I highly recommend. But you need to have a page somewhere where you write down all of your stuff, all your formulas, so that they're right there when you need them. Okay, so in these cases, what we're going to be doing is we're going to be imagining what the base of the object looks like. And the base would be the bottom, right? The part that's sitting on the table. We're going to find the area of that, and then we're going to multiply up by the height. So how do we find the area of this base, which I'm kind of coloring in so you can see? All right, well, the area of the base, which I abbreviate as AB, so I don't have to write it out every time, is going to be this dimension, 13, times this dimension, 6. Okay. And that is, let's see, 6 times 3 is 18. So I'll write down the 8 and I'll carry the 1. 6 times 1 is 6, plus 1 more is 7. So the area of the base is 78. But now we have to multiply it by the height. And the height is 5. Five times 8 is 40. 35, 39, and then we put the unit on it at the very end. We figure out what our unit is measured as, feet. There's nothing complicated about that. We just copy the word. And then, like I said, volume is always a cube, so we can write the answer like that. That's my preference, but I noticed that your materials write this, cubic feet. This is just an abbreviation for that. So either one of these answers is fabulous, and I'm pretty sure that's the right answer that's given for you, okay? That's the formula that makes this all happen. Now, I was gonna skip over the next problem and let you handle it yourself, but then I noticed a little problem in it. The volume of a 3 centimeter cube. Okay, let's draw it. Kind of fun, right? Don't you love drawing these 3-dimensional things? I remember when I first learned how to draw a cube like this, and I was pretty sure I was a genius. I was so excited about that. All right. And again, it doesn't have to be perfect, just close. So it's a 3 centimeter cube, which means that this dimension is 3, and this dimension is 3, and then this one is also 3. Okay, so we know that the volume of our shape is the area of the base times the height. That's my shorthand version. The first time I wrote out the words, this is my shorthand version. The area of the base is this. So the area of the base equals 3 times 3, which is 9. And then we're going to multiply that by the height per our formula. I go back and forth between dots and X's. It doesn't have any meaning or significance whatsoever. It's just whatever's on my mind. Actually, when I go horizontally like this, I usually use a dot. But when I go up and down, I go back to the old school X. In any case, we're going to multiply that by the height, which is 3 again. I don't want to write it there. I want to write it there. And so our answer should be 27 cubic centimeters. That's the right answer, but I noticed that in the book, the answer, I noticed that somebody, I don't know if it's you, has penciled in a circle around the right answer. They circled 9, but that's, unless I read the problem wrong and it was just asking for the area of the base, the volume is 27 centimeters, which was one of the choices. So I'm not sure, but check that out and make sure that you have exactly the right answer. Again, if maybe it was asking, now that I think of it, I don't remember reading specifically that it was asking for the volume, but the volume is that for sure. All right, so let's move on to the third one. For the third one, I just copied the picture and the words and the numbers that they had. And this is a little confusing. This is a triangle that's standing up, and the words don't make as much sense as to how, like 2 is this dimension, but they're calling that the height. This is a big clue. What this says is this, we need to take this block and knock it down. What we need to do is we need to redraw this shape like this kind of, right? So that it's, oh wait, no, that's not right. Sorry. We need to draw it so the triangle is lying down. Well, no, that was kind of right. And then this part is, it's looking too much like that one. This triangle is the base, okay? Just like this is the base, we need to imagine the triangle, and I'm just struggling all of a sudden. I think the Seahawks made me crazy today, and I can't even think of how to draw a triangle lying down. But this is the base. We want the wonky shape to be the base, and that is a rule of that is a rule to remember. The wonky side is the base. Because we can figure out the area of wonky sides, but then we just want to multiply it by the height and go straight up. So the area of this base, it's a triangle. We know that the area of a triangle equals base times height over 2. So the base here is 6. And not this height, but this is the height of the triangle, right? That's 4 divided by 2, and that's going to give us 12. And then we multiply that by the height here, and that gives us 24. All right, so we have to visually take that triangle and lay it down so that this area is the base, the 4 times the 6, and then we multiply it by the height by imagining that's going straight up. I hope I didn't confuse you too much on that. This is the right answer. 24 cubic centimeters. All right, those were the 3 problems you gave me on volume. I hope that is illuminating. Again, our formula is to find the area of the base times the height, and we can reorient the picture to make the base be any side that we want. We want to make it, we want the wonkiest side to be the base, because we can find the area of wonky shapes, but we don't want to have to multiply by the height in a wonky way. All right. That's it for that section. Let me know how it goes.